Alright, let's go ahead and make, this might be the last video. This will be pertaining to the sections of the test that were on separation of a sand-salt mixture. So the experiment that we had performed that the test questions were based on were dealing with this system here in this picture. Which one of the following principles was used to separate the two chemicals? And that is gravity filtration. It's just gravity that pulls the solution down through the filter and separates the dissolved salt from the sand. Alright, one of the test questions was the filter paper weighed 0.65 grams if 1 gram of the mixture of sand and salt went into the filter cone. I've labeled that here in the picture. We have 1 gram for the solution, 0.65 grams in the filter paper, and it said 0.25 grams of sand based on the filter and dried paper being 0.9 grams, and when you subtract out the dried filter by itself from 0.9, you get 0.25. Which one of the following best explains why after filtering and drying the filter paper it weighed 0.9 grams? So I went ahead and attached to this little table all of the numbers that it's giving us. It says we started with 1 gram of a mixture of sand and salt, so I put that here, and 0.65 grams of the dry filter paper by itself. Then the dried filter paper after filtering was 0.9. This question asks which of the following best explained why, and the answer is because 0.25 grams of sand was up in there. So 0.65 dry paper plus 0.25 grams equals 0.9 gram of the filtered and dried paper with the sand in it. How much salt would have been down in the bottom of the flask dissolved? We started with 1 gram of the mixture here, and since 0.25 grams of sand got stuck in the filter, 0.75 is here. And I've shown all the work except, now that I'm thinking about it, I probably should have shown, no, there's no math here. It actually tells you the filter and dried paper is 0.9 grams with the sand in it. Alright, so this one. Looks like my computer is lagging a bit. What is the mass percent of the sand in the sand salt starting mixture? So we know we had 1 gram of sand salt mixture, and 0.25 grams get stuck in it of the sand. So what percent is that? So you do mass of sand, which is 0.25 grams, mass of the mixture, which is 1 gram, times 100 equals 25% sand in the mixture. Alright, moving on. If the dried paper weighed 0.65 grams, and after filtering the dried paper had 0.3 grams of sand in it, then how much of your 1 gram starting mixture was salt? So let's just go ahead and organize the numbers it's giving us. Mixture of sand salt 1 gram, filter paper again 0.65. It said the paper has 0.3 grams of sand in it. So if the paper has 0.3 grams of sand in it and we started with 1, that means we should have 0.7 grams of salt in it, because 1 minus the sand, which is 0.3, is 0.7 grams of salt. Next similar problem, if a 1.1 gram salt sand mixture is separated and the salt weighs 0.1 grams, then the sand weighs what? So we have a mixture of sand salt again. It's 1.10 grams over here. The filter paper, this problem doesn't require you to do any addition or subtraction with it. It just straight up tells you that the salt weighs 0.1 grams. Therefore, of your 1.1 grams starting material, what must the sand weigh? It's 1.1 gram minus 0.1 gram equals 1. So that one's easy. Looking at another one, if a 1.6 gram sand salt mixture is separated, and the salt water in the bottom of the flask contains 0.6 grams of salt, then there's how much sand present. So now our starting material is 1.6. You don't need to know the paper again. It says 0.6 grams of salt, so how much sand is there? 1.6 minus 0.6 is 1 gram. That's how much sand would be present. Alright, let's do another mass percent problem. So this will be our second mass percent one. What is the mass percent of the sand in the sand salt starting mixture in this problem here? So we have 1.6 grams of sand and salt. We have the filter paper and the dried filter paper with sand. You don't need to know that. The sand in the paper is 1.6 minus 0.6 because the salt was 0.6. So that's going to give us 1 gram of sand. Problem's asking us for the percent of sand by mass. So we have 1 gram of sand divided by 1.6 grams of the mixture times 100 equals 62.5. Now let's do the salt. What's the mass percent of the salt? We know that there's 0.6 grams of salt according to the problem, and the mass of the mixture is 1.6. So 0.6 divided by 1.6 times 100 equals 37.5. And finally, since we did just do both mass percents, these should equal 100, and that's the case. 37.5% of salt plus 62.5% of sand equals 100% salt sand. I think this might be the last thing. When you added the saltwater sand mixture to the funnel and filter cone, where did the salt water go? It went down through the filter, down at the bottom here, into the conical flask. I think that is the last one. Yep. Okay, let's go back up though. One thing I did want to mention, when I was giving you the grams of just the salt, notice I am saying we're ignoring the water mass. That's an important thing that I wrote in an earlier problem, I think. Yeah, so we're ignoring the water in this case, where we're just saying 0.7 grams of just salt. And that's kind of important. Might have had a student being like, wait a minute, this doesn't make sense because we added like 10 grams of water or something like that, or 100 grams of water. Well, we're just talking about the salt. Imagine if we did evaporate off that water, we'd have 0.7 grams of just salt. Alright, that's it for this video. Hope you get it. If not, oops, my bad.